Hi folks, Joseph Kursky here with you to talk about geospatial data, how to find it, how to assess it, how to teach about it, and why it all matters. Thanks for being with me. The purpose of this presentation is to do four things. Empower you with skills to find geospatial data for your teaching, your research, or your project. Number two, to enable you to be able to make wise, smart decisions about whether your data is appropriate for your needs. Number three, provide you with resources to teach societal issues surrounding data, such as location privacy, data quality, copyright, and ethics. And fourth, connect you with and to available ESRI resources for support and further learning. Let's get started. Now, admittedly, data is a topic that it can seem a bit dry and boring, right? However, I submit to you all that it is key to GIS, to instruction, to empowering students and colleagues to be change agents in their communities and in their world, no matter what profession they go into. Data is a key component of GIS. It always has been from the inception of GIS back in the 1960s. GIS contains software, increasingly in the cloud, software as a service, information products, data, spatial data, location-based data, hardware, people, and procedures or a process or methods. Geospatial data, as a reminder, has some important characteristics. This is not a all-encompassing list, but it's tied to location. It's got a street address, a latitude, longitude, a place name, something that ties it to a location. Now that location could be on, above, or below the surface of the Earth. It could be in the oceans. It could be on Mars. It has to do with a location. It's often combined with attribute information, the water quality, the population of a place, the demographics of a place, the characteristics of the biome, etc. It often contains a temporal component, a time component, and it can be generated in a widening variety of ways. Crowdsourced surveys, for example, from Survey 123 or Quick Capture, machine learning or artificial intelligence techniques, feeds from the Internet of Things, traffic cams, stream gauges, etc., UAVs or drones and other expanding remote sensing techniques and platforms, unstructured data, a PDF, for example, tabular data, and much more. There are an expanding array of geospatial data sources as well. Tables and spreadsheets, field surveys, field observations, even notes, imagery from aircraft, UAVs, satellites, grids, tiles, GeoJSON, and other widening, expanding sets of formats, shapefiles, geodatabases, ground photographs, IoT feeds, again, stream gauges, traffic cams, sensors of all kinds, augmented reality, 2D and 3D maps and visualizations, and many more sources for geospatial data. I won't go into the extensive history behind geospatial data, but in short, geospatial data didn't just appear overnight. In the early days of GIS, geospatial data was created from the paper or analog aerial photos, topographic maps, census demographic maps, etc. Now GIS is actually used to generate any sort of media-based, paper-based items, which are increasingly fewer and farther between as people want to consume the digital information. But geospatial data has a long history going back to the analog paper mapping and surveying days. That provided the foundation for some of geospatial data, especially in the early days of GIS from the 1960s to about 2000. And since then, these expanding platforms, sensors, etc., ways of generating geospatial data have far outstripped anything that we did in the analog days of mapping. But in the past, it was very difficult to store geospatial data, serve that data, find that data, and access that data. In the early days of GIS, once again, it was all on physical media, magnetic tape, disks, and other means. Now with the web, that has of course greatly expanded the array, the variety, the volume, as we'll see, of geospatial data. But it was difficult in the old days for data providers to serve the data and for data users to access the data. Today, geospatial data, no surprise to you all listening to this, I'm sure, but is offered with a greater variety, volume, and accessibility than ever before. There's no shortage of data nowadays, folks. It also frequently includes a temporal aspect. You can access it on any device more and more frequently, anywhere, anytime, by anyone. It's truly an amazing world that we're living in. But it also has important implications for our decision making and our instruction. Today, geospatial data can be accessed as downloadable files, which has been the case for decades, and increasingly nowadays as streaming services, data as a service. Data as services is an enormous leap forward in many ways. We'll talk about a few of those in this presentation. Here on this slide, you can see some of the ways that geospatial data is being served. Let's discuss two examples of the traditional way of obtaining data versus today's streaming and other methods. First, census demographics. The traditional ways are still with us and will be with us for some data sets for the foreseeable future. But where these new methods that I'll describe exist, use them. Use the streaming methods. Faster, more reliable updates in near real time or real time makes your life a lot easier to consume data. The traditional method in this example is that, let's say you wanted to obtain some demographic data for the US. You would go to the Census Bureau's Tiger files, which have the geometry for census tracts, block groups, counties, political and statistical areas. You'd have to then get the tables of the demographic data and join them to the Tiger files, to the geometry, and then have to deal with things like field names are very difficult to determine. P001-0001 is total population. P001-0002 is median age, etc. You'd have to deal with all of that, and it was a long multi-step process. It still is. It only works for one level of geography at a time, census tract, block groups, zip codes, etc. The data also is static. You have to keep doing this process, keep downloading this process for updated data. And you have to repeat it for different countries if you want to do this in another country besides the US. And it's also very much tied to desktop GIS. The new method in this particular example is you stream the demographics from ArcGIS Living Atlas of the World directly into your GIS project, whether it's in ArcGIS Online or ArcGIS Pro. So you've got multiple software that it works with. It works for many countries around the world. The data often updates automatically. It's multi-scale, so as you zoom in, you see the census tracts and then the block groups, for example, and zoom out, you see census tracts and zip codes and counties as a US example. There's no processing of the data. There's no dealing with attributes that don't make any sense that you have to translate the field names. And it reduces the data acquisition time from hours to literally minutes. Now, let's say someone says, but Joseph, those long multi-step processes built some skills in students. Admittedly true. But I would submit to you all that there are more efficient ways to building some of those skills, like joining tables, for example. I personally can relate. I found it difficult to give up my carefully prepared 40-page census Tiger lessons that I had created over the years, and you probably did the same thing. But I needed to. Plus, graduates in the workplace are very seldom going to be asked to go through these traditional methods much longer. Now let's examine an elevation example. The traditional method of obtaining elevation data is you'd go to nationalmap.gov or some other portal. You'd download that data to your GIS software. You'd create your hillshades, your slopes, your aspects, and other derivative products in your GIS software. The disadvantages to that method is that it was a long process to download individual blocks, sometimes 7.5-minute tiles, of terrain data. And then you'd have to create the products one at a time. Then you'd have to join them all together or stitch them all together. You might have edge matching issues, etc. It's also tied to desktop GIS. And you'd have to repeat it for multiple areas or even multiple countries outside the US. The new method is you stream the elevation service from ArcGIS Living Atlas of the World, once again, starting to sound familiar, directly to your GIS project. Advantages there: reduces the data acquisition time from hours to minutes, no processing of the data required, no edges to match. You can stream the data to match the boundaries of your watershed or your county or your other area of study. You can use it in ArcGIS Online as well as ArcGIS Pro. It's multi-scale. Derivative products also are sometimes available as services. In other words, the hillshades, the aspects, the slope, those are oftentimes services as well. And some of these data sets are global. I'd like to emphasize here that these windows into the future, which are actually present-day realities, are an indication to me that this is just the beginning. In other words, this new method of accessing data, we're just at the beginning stages, folks. Now, one could argue that geospatial data was always big data, for example, as the GIS community has always been keen on accessing and using large amounts of vector and raster data. Yeah, more data. But truly big geospatial data is starting to arrive. Now, working with these very large data sets requires data warehousing, distributed computing, analytics in the cloud, libraries and binaries, and tools such as the Esri Geospatial Cloud, GeoEvent Server, ArcGIS GeoAnalytics Server, ArcGIS Image Server, and other enterprise solutions. And this will require people who understand GIS analytics, but also from a systems perspective and with web tools. Now, people who embrace this, they're going to need some different GIS skills, which will build on what we've done so far, but how do we teach those skills? How can we embrace this? I would recommend starting small. For example, start with the Microsoft Buildings layer for the USA. It's got millions of buildings in it, and you can start analyzing it in ArcGIS Online and in ArcGIS Pro. So starts with something that's doable, but it touches on this big data world. And for more, see this Esri article on real-time big data analytics. This could be a whole presentation by itself, but I just wanted to get you thinking about the coming avalanche of requirements and truly big data in the geospatial world. Data skills are in high demand in GIS-related positions, but also in non-GIS positions alike, in a wide variety from anthropology to zoology, A to Z. Big data skills are in high demand. Be purposeful about teaching with and about data. More about this in a bit, but this is a key part of the skills you are building in students. This is from a job posting of a GIS specialist in landscape biology and ecology on geosearch.com, December 2021. Notice this is just a section of the job posting. Notice all the data references. This is just one of hundreds of jobs that are focused on solving problems, but they require people to be adept, skilled, cognizant, aware of how to work with data. What data skills are in demand? Here are just a few of them. Scan this for a moment and see that it ranges from generating to curating. Gosh, with the GIS cloud, you put data out there in the cloud, you're going to have to curate it. You've got to maintain it. You can't just put it up there and just let it sit for lots of reasons. We have a dynamic planet, this planet Earth. We've got to understand the planet and all of its multifaceted systems and cycles, the hydrologic cycle, the carbon cycle, and the spheres, the anthrosphere, the hydrosphere, the lithosphere, the biosphere, etc. So spheres, systems, and cycles. We've got to understand all that. The system of systems is really what the Earth is, and that's what geospatial technology is also, a system of systems. So data is central to understanding the world, and these skills are highly in demand, and will continue to be so. Indeed, data science, as I'm sure many of you are aware, has emerged in the job market and is also offered as a discipline, a degree program, a certificate in many university and college programs. These are just a few right here, but there are hundreds of these that have appeared over the last few years. Even in high schools, some data science courses. Using a variety of data, and I'll have more teaching tips in a bit, but it makes your educational program, whatever discipline you happen to be teaching in, vibrant, interesting, and relevant to a wider diversity of students. So keep that variety of data that you're having students analyze in a variety of ways, diverse, multi-scale, maybe touching on some key issues of our 21st century world. Population change, biodiversity loss, climate, energy, water, etc. The UN Sustainable Development Goals, for example. Keeping that data of a wide variety will help your program and help your students. I think it's important at this point to talk about what is a modern GIS. A modern GIS is anchored in this geospatial cloud. It's a system of systems. It includes software, apps, such as dashboards, story maps, web app builder apps, experience builder apps, information products, communicating about a geospatially related problem or issue. Data, as we're talking about right now, hardware, people, and a process. Data is central to modern GIS workflows and the whole technology that is modern web-based GIS. Data is not a component of modern GIS. It is really central to all of it. The process, the structure, the infrastructure of the paradigm, the idea of modern GIS. Data is central to all of it, how it's served, how it's accessed, how it's assessed, etc. Data is also integral to this notion of GIS as a service, or GAS, GIS as a service, cloud-based GIS. The first step is simply getting access to this. So how do you access this cloud-based GIS with a tablet or a browser to access a vast amount of services, data, and applications? And this whole GIS as a service is different. It's got data from the Living Atlas, services, servers from anywhere around the world. They're oftentimes real time. They are based a lot of times on imagery, historical data as well. They also have analytics in this GIS as a service, and they have applications, the ability to quickly configure and share data and results with anyone on any device.